All right, how you guys doing today? So, just received some word yesterday that the New York State Regents exam is going to be canceled for June. I'm not exactly sure what that means, and I'll give you more information on that as I know it. I don't know if that means that we're going to take it in August, you're going to take it next year, or if you'll just receive credit for taking it. So, not really sure as far as that goes. But we're going to kind of continue on here today, and I'm going to try and teach you another quick math lesson. So, yesterday, we did some solving quadratics by using difference of perfect squares. So we saw stuff like x squared minus 36 equals 0. And we said, oh, that's a difference of perfect squares. So we wrote this as x plus 6, x minus 6 equal to 0. And we went ahead and solved each piece of this. X plus 6 equals 0, x minus 6 equals 0. And so we said that x was equal to negative 6. And at the same time, we said that x was equal to positive 6. Now that way wasn't particularly difficult, but I just want to show you another way that you can do these problems. You may find it easier, you may not. But the good thing about this next method I'm going to teach you is it doesn't necessarily have to be a perfect square. So we could solve this problem, x squared minus 36 is equal to 0, just like if we had a regular equation where we're trying to get x by itself. We can do that because we only have one x here. Once you start dealing with multiple x's, that becomes more difficult when we can't combine them. But here, I can simply add 36 to both sides. I get x squared is equal to 36. And then I can take the square root of both sides. It is going to be important that you realize that when you take the square root, there's going to be two answers, a positive and a negative 6. So this is called our square root method. It will give you the same exact answer that we did if we had a difference of perfect squares. Just another way for you to do this. Some of you may like it more, some of you may not, but I'll show you a couple other examples and how this can be helpful. So this next example here, x squared plus 10 is equal to 26. Now, in this particular example, I could try to move my 26 over to create a difference of perfect squares, but I'm going to use the square root method, and so I'm just going to subtract 10 on both sides. I'm going to get x squared is equal to 16. And then to get rid of my squared, I'm going to take a square root, and I'm going to get x is equal to a positive and negative 4. So I think this method's a little bit easier, a little bit more straightforward, but I'll let you guys be the judge of that. All right, one final example I want to show you, because we've gotten kind of used to solving these quadratics and getting two different roots each time, which does happen a lot. If that happens, that means that in this particular example, our parabola probably looks something like this. It's crossing at two separate spots. In this case, negative 4 and positive 4. But from when we've done parabolas, you know that it's not always going to cross here at two different spots. There's going to be times where it's only going to cross here once, or sometimes where it won't cross here at all. So let's take a look at this next example here. X squared minus 2 equals negative 10. So if I was trying to solve this using my square root method, I would add 2 to both sides. I'd get x squared equals negative 10 plus 2, which is negative 8. And then I take the square root. Now, many of you, probably just kind of on autopilot, would immediately go to your calculators and try to type in the square root of negative 8. if you do that, your calculator is going to pop up with a message that says error, non-real answers. That's because we can't take the square root of a negative number. It's not possible for us to come up with two numbers that multiply together to give me -8. So there is no real solution here, or no real answer. What this means is that your parabola, and I don't know exactly what this particular parabola is going to look like, I'm just going to kind of guesstimate, would look something like this. So you'll notice your parabola does not cross the x-axis at all. It starts up here and never actually crosses, so we have no roots here, or no x-intercepts in this particular example. So just be aware that as some of these problems come, it is going to be possible that you get some that don't have a real solution or don't have a real answer. All right, that's going to do it for today. Hopefully this helped you out, and hopefully I get to see you guys all soon.